Okay, kids. Yesterday's notes basically introduced you to covalent bonds and a single covalent bond. Okay. We're going to look at multiple covalent bonds today, namely a double and a triple. So the title of this one is Multiple Covalent Bonds.
We didn't get past 4A. Were we going to do 3A too? On our notes? We only looked
Yeah, we got
at
through 4A elements.
and then we stopped after 4A.
Yeah, that's it.
Okay.
That's it. Multiple covalent bonds.
Thank you.
Atoms can share more than one pair of electrons in a molecule. In order to attain,
We can't really see
my bad, all you gotta do is tell me. Thank you. In order to attain a noble gas configuration, the number of valence electrons of an element is associated with the number of shared electron pairs needed to complete the octet and gives a clue as to how many covalent bonds can form. That's like a run-on sentence, isn't it? I want to take you back to yesterday's diagrams that we did. And I want you to be sure that you understand. This is what we call a single covalent bond. Okay? Right here, single covalent bond. Single, single, single. Okay? Even though there's two, each one is a single covalent bond. Okay? And I'm doing this for a reason. Now, how many single covalent bonds are here?
Three.
3. Okay? This one is how many singles? Because each covalent bond is one shared pair. And there's a point to this. Okay, and how many single covalent bonds here? 4. Okay. Double and triple covalent bonds are examples of multiple bonds. So everything I just showed you on yesterday's notes is not what we call a double and a triple. And that's the point I wanted to make. They were single covalent bonds. Okay, definition, double covalent bond. Hello? No, I thought he was with y'all. Okay, haven't seen him this morning. Bye. Double covalent bond. Share 2 pair of electrons. Okay, now this is going to be a different situation than yesterday's. Okay, example. Whoa, that's not a T, that's an L. O2. That's so stupid. Example. All right. How many oxygens are we going to draw?
2.
Okay, so we got 1 O. Each oxygen brings how many valence electrons, kids? Look up at your group A number. 6. All right, so I'm going to do my double up on the top and the left side because I want you to be able to see more closely where those singles are. Okay? And we're going to do this one over here with the double on the top and the double on this side, and we're going to see the singles down at the bottom and together. So we've got 2 O's that are going to come together and form what we call a double covalent bond. Can you see this and this pairing up? Yes? Okay. So what that is going to look like, okay, now we're going to draw our 2 O's together again, but we're going to put them about like yay, okay? Now then, put your pairs where they were on the other diagram. Okay? Now then, where we're pairing these 2 up, there's 1 pair, there's 2 pair. Okay? Now, can you see that this is a double bond in the middle? Everybody see that? Okay. Do you see that? And there's multiple ways to draw this. These, it could also look like this. Your double bond in the middle, and you can have top and bottom. It doesn't really matter. Okay? Works the same way. Now then, Venn diagram. How many does each oxygen have to have? 8. 8. Put your finger right here. 2, 4, 6, 8. Does everybody see that?
Yes.
Okay. So this is your first circle. Okay. And this is your second circle. Now, taking you back to yesterday, let me make sure that you can distinguish the difference. Okay, inside the Venn diagram, how many shared pair do you see? 2. This 2 shared pair here inside the Venn diagram equals a what kind of bond? Double. Covalent bond. Okay? Now if you look at these, how many shared pair do you see inside your Venn diagram? 1. See, there's only 1 inside any of these. Okay? Singles. They're all singles. All right. Now then, another way that you can see this drawn, instead of using dots in the shared pair, you can use what did we learn yesterday? Straight lines. Yes. So let's do this one again, the oxygen, and we're going to substitute the 2 straight lines, okay? And you can put your dots either way. Just recognize that you can see it different ways with these unshared pairs. Okay? Questions? Okay, here's your double bond. These are your unshared pair electrons. Okay. Now we're going to look at a triple bond. Definition, triple covalent bond. Triple, how many are they going to have? 3. Mm-hmm. 3 shared pair. Of electrons between 2 atoms. Oh, let me go back and look at this. Everybody, you have your notes from yesterday kind of handy? What was O2 called? What was it a member of?
Diatomic molecules.
Diatomic molecules. Okay? Diatomic molecule. And we're going to learn how to memorize those. Okay. So, our next example is N2. So, what do you think it is? What is it? Diatomic. What does that 2 mean? Di. 2 atoms. Okay. So, the N is in what group, kids? 15 or 5A? Everybody see it? I go by 5s. Why do I go by 5?
Because that's an advanced electron mass.
Exactly. Group 5A equals 5 valence electrons. Okay. So we've got 2 N's. Each N has how many? 5. So we're going to put the doubled up at the top with a single around. Okay, does each N have 5?
Yes.
All right. Now then, can you see where the triple bond is going to come from? See the 3 singles on each end? Okay. So basically, we're going to show these singles all hooked together in the center between the 2 ends. Okay? So this is going to go to N with how many bonds in the middle?
6 or 3.
3. 3 shared pair in the middle between the 2 ends. Now can you see where the triple comes from? Okay? Now then, technically, most of the time you'll see these unshared pair on the outside, basically. But you can, just depends on who's drawing them. All right? So this is known as what kind of bond?
Triple covalent.
Okay. Venn diagram. Put your finger over here. So 1, 2, 3, 4, 5, 6, 7, 8. Put your finger over here. 6 in here, 7, 8. Does everybody see that? Okay. So right here and right there. And in the center of that shared area, you see your triple bond. Okay? Now then, how else can we see this drawn?
3 lines.
Okay, so we've got our N, 3 lines in the middle, our N, and your unshared pairs on the outside. Questions? And we'll be doing a lot more of this, drawing these Lewis dot structures. Okay, we're going to move on now to strength of covalent bonds. As the number of shared pairs of electrons increases, bond length decreases. As the number of shared pairs of electrons increases, bond length decreases. Okay, single bond. Longest bond length. Double bond. Not as long as the single. Triple bond. Not as long as the double. Okay, so if you read this statement here, as the number of shared pairs of electrons increases, bond length does what?
Decrease.
Okay, so the single bond has the longest bond length. Now when you get to a double, okay, that length has shortened, hasn't it? When you get to the triple, okay, it has shortened. So the triple is the shortest length and the single is the longest. Okay, so the triple is the shortest. And this one is the longest. Okay. Now, from that, put a star by this. The shorter the bond length, the stronger the bond. Okay, so who's going to be the strongest bond? Absolutely. So the single bond equals the weakest. The double is in the middle. Stronger than single. But what? Weaker than triple. And then, of course, the triple equals the strongest bond. Questions? Okay. So, everybody caught up with me? Okay. When bonds form between elements and when bonds are broken in chemical reactions and new bonds formed, all of that is identified and requires a change in energy. Either energy will be lost not lost, but given off, or it will require energy to be absorbed. So energy is a key factor in bonding. And energy change accompanies the forming or breaking of a bond between atoms in a molecule. Star this, please. Energy is released when a bond forms hence the lower potential energy and greater stability. Prime example, kids, equal your diatomic molecules. That's why they do not run around in nature as single hydrogen, nitrogen, oxygen, or fluorine, or chlorine, or bromine, or iodine. Because this lowers their potential energy and gives them greater what? Stability. Hello? Never showed up. Bye. Everybody know where Caden is? He didn't show up for his hostess stuff. That's them looking for him.
He was getting kind of sick yesterday, I think.
Was he?
Yeah, he was having more bad, like, overdose and stuff, so.
Okay.
I don't know.
All right. Here we go with the naming and formula writing. Y'all are going to love this one. And I'm not saying that sarcastically. I'm saying it that you will really love this compared to...
It's easy.
yes.
Thank God.
Okay. Rules for naming binary molecular compounds. Binary molecular compounds. Okay, rule 1. First element in a formula everybody remember that these are non-metal plus a what? Back in your notes yesterday, there'll be 2 non-metals. Okay, no metals in these at all. None. First element in a formula is always named first. Using the entire element name. Okay, if you look right up there above the zigzag, carbon. entire element name: nitrogen, silicon, phosphorus, oxygen, sulfur, arsenic, selenium, tellurium, fluorine, chlorine, bromine, iodine. Okay? Using the entire element what?
Name.
Okay. 2. The second element is named using the root of the element and adding the suffix IDE. So binary covalent compounds, I'm going to put covalent up here. Rules for naming binary what? When you see the word molecule, it's always referring to covalent bonded molecules. Okay. So they're all going to end in what?
IDE.
Okay. Binary means how many elements? 2. Okay. Rule 3. Prefixes are used to indicate the number of atoms. All right, and from these prefixes,
Could you move it up, please?
yep. Let me see how I'm going to do this. The last name always has a prefix. Which one? Always. Now then, there's one exception for the first name. The first name will always, whoa, how you spell ways? Have a prefix except, here's your exception, for it will never have mono.
If there's not one, it's just mono.
See, mono is one, but the first name will never use mono. It will, so if it's just one of the element, it'll just be the element name, like sulfur, not monosulfur. Okay? All right, now, our prefixes and numbers of atoms. All right, we're going to do a little table here. Number of atoms. Prefix. Number of atoms. prefix. We're going to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's our little table, so to speak. I'll let you catch up with me. Everybody good?
Yes, ma'am.
Okay. For the prefix mono goes with 1. 2 is what? Di. 3 is what? It is. 4 is tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. 10 is deca. And there are your prefixes that will be used in the naming and indicating the number of atoms for when you write formulas. Okay? Alright. Example. CCl4. Binary. Who is C?
Carbon.
Okay, remember the first name, single, never gets mono. So its first name is carbon. Look at your prefix. How many?
There's
Tetrachloride.
There's 4. So you go look and you put, see the 4?
Tetrachloride.
Exactly. Tetra,
Oh.
tetra, chloride. I told you. Okay. As2O3. Now you've got 2 arsenics. What's the prefix for 2?
Diarsenic.
Di. And then the element's name. Arsenic. How many oxygens?
Trioxide.
Correct. Remember, they all end in what? IDE. Okay. CO. First element never gets mono, so what's its first name?
Carbon monoxide.
Carbon monoxide. Oh, that's some deadly stuff.
That is deadly. And then mon. Now when you got 2 vowels coming together, drop the A. Mon oxide.
That's
Carbon
that's
monoxide.
That's what comes out of vehicles, right?
Yes, that's what kills you.
Yeah, that's why people stuff their tailpipes when they want to commit suicide.
Okay. See, instead of writing monoxide, okay, you drop. When you got 2 vowels coming together, drop it. Okay, so single, what's its name?
Sulfur
Sulfur
dioxide.
You spelled sulfur wrong.
I did. Thank you. Okay, now reverse.
Name.
Silicon formula writing. Dioxide. How many silicons?
1,
So Si. How many oxygens?
2,
O2.
That's
Triphosphorus pentasulfide.
So it'd be
So it'd be
P3 S.
S5.
Exactly. The formula is based off of the prefixes. Does everybody see that?
Yes.
Dicarbon tetrabromide.
Oh.
Di means how many?
C2B4.
C2, BR, 4. Did I tell you you were going to like this one?
Yes.
Alright. Y'all can put up, I'm going to do penta, sulfur, hexa, nitride. S5, N6. There you go. Alright, you've got your little worksheet.